Hi there, in this lesson we're looking at parabolas as conic sections, and if you're watching this, it means that you've dealt with parabolas before and we've kind of figured out how to graph these things and the different pieces of these, but now we're going to look at it as it pertains to conic sections, which just means we're going to do a little bit of review of parabolas, and we're also going to add a couple pieces to these things, alright? So first of all, let's talk about conic sections. Conic sections are cross sections of a cone, and a cross section of something is when I slice it open and look at it from the side view. All right. So as I start slicing a cone in different ways, if I slice just the edge off of a cone, the shape that I'm left with when I look at this from the side is a parabola. All right. And a couple of review pieces about a parabola. The parabola starts with a vertex. That's the most important point that we need to find. And the vertex is either the maximum or the minimum point. If I have a parabola that opens down, I get a maximum for my vertex. If I have a parabola that opens up, I get a minimum for my vertex. All right, so this is the vertex. And remember, finding the vertex, in case we've forgotten, our formula for the vertex is the opposite of b over 2a. That gives the first value, and then we have to plug that in. Okay, so that's how we find our vertex. The axis of symmetry. The axis of symmetry always passes through the vertex, and it's a line over which the parabola is reflected. So again, when I draw the axis of symmetry, it always goes through the vertex. There's my vertex. And we always draw it as a dotted line. Okay? And what's going to happen here is we're basically going to reflect every single point that's on one side is matched up on the other side. And remember, previously, our equation for this thing was always x equals the opposite of b over 2a. All right? And that's pretty much going to stay the same. As we look at the vertex and the axis of symmetry, this is going to change slightly as we look at conic sections, because we're not only going to look at parabolas that open up and down, we're also going to look at parabolas that open left and right. So when we talk about maximum and minimum, we might be talking about a maximum left and a maximum right on this thing as well. All right? And when we talk about the axis of symmetry, we might have the equation y equals this thing, because we'll have the equation of a horizontal line. So keep that in mind as we move forward. We will do a couple examples turning these things sideways. All right. To add to these, we're also going to talk about the focus. The focus of a parabola is a point inside the parabola, and it's important to know that it's inside. It's always inside the parabola, through which all parallel rays are reflected. All right. And to get to the focal point, we use the focal length. That's the distance from the parabola to the focus. And it's given by this equation 1 over 4a. All right? So if I do 1 over 4a, that tells me how far away the focal point is, and then I can just count from the vertex to the focal point. All right? And so here's what this thing looks like. If I have a parabolic curve here, and I start shooting parallel rays into this thing, and when I talk about a parabolic curve, let's say maybe this thing is a mirror and these are rays of light, what's going to happen is they're going to bounce off, and they're going to... Well, that started to get a little bit ugly. Let me try that again. They're going to bounce off of this thing, and they're going to go to a very specific point inside this parabola. Okay? And if I were to shoot another ray in here, what's going to happen is it's going to bounce off, and it's going to go through a very specific point inside this parabola. And if I keep doing this, if I do a couple more here, maybe I'll put one down here. Going to bounce off, and it's going to go through a very specific point. And so all of them congregate around this one single point, and no matter where I hit on this thing, I missed a little bit, it's going to bounce off and go through that specific focal point. Okay, so all of them are going to pass through the same point. They're going to bounce off and go to a focal point, and this is how things like glasses work, or contact lenses. This is how your eye works. Basically, the lens is a parabolic curve, and it's focusing these things into a specific spot. All right. When you wear glasses, it's refocusing the light so that it hits, your eye at the proper angle, so it corrects your vision and makes things clearer. Magnifying glasses work the same way. All right. So again, we're landing on this center focal point. Okay. The other thing we have, and this really isn't that useful, but we'll talk about it anyway, is the directrix, and this is a line that's perpendicular to the axis of symmetry, whose distance from the parabola is equal to the distance from the parabola to the focus. In other words, if I have a parabolic curve here, and I've got a focal point that's right here, the directrix would be over here. All right. because you can see in this particular example my axis of symmetry is horizontal, so that means my directrix is perpendicular to that. All right, and the idea here is that the distance right here, and we mentioned this above, is 1 over 4a. That's the focal length. Well, the distance right here is also 1 over 4a. All right, so that can lead us to where this thing is located. But the interesting thing about this is if I measure any of these distances, if I measure the distance here to the parabola, it's the same as the distance from the directrix to the parabola. All right, and no matter where I go on that parabola, the distance between the focus and the parabola is the same as distance from the parabola to the directrix. Okay, so really this is just a linear representation of our focal point. Okay, so here's how this works if we want to graph a couple of these. If I look at this one, I'll find the same things that I normally find. So I'll find the vertex and the axis of symmetry. Then I'll draw the graph, and then I'll determine the focus and the directrix. Okay. So if I do the vertex, again, vertex is opposite of b over 2a. So I do the opposite of b over 2 times a negative 1/2. And it looks like that's going to give me 2 over a negative 1, which is a negative 2. So remember, that's just my x value for my vertex this time. And then I just have to plug this back in. When I plug it back in, it looks like it gives me a 5. The axis of symmetry is just x equals the x value from the vertex. It's the negative 2. And now from here, let's graph this thing. Since we know how to graph these, I'm going to start with my vertex, negative 2, 5. It's right here. I know the, I can also see the y-intercept if I want to use that. The y-intercept is positive 3. But I can also use the shape of this thing and the axis of symmetry. I know this thing's going to open down because the a value is negative, and it's going to be half the size of my regular parabola, so instead of over 1, down 1, I go down a half. Next one, instead of down 4, I go down 2. And I can reflect each of these points. Over 3, instead of down to 9, I'm going to go down 4.5. Having a little trouble counting apparently today. So I go down 4.5, and I could keep doing that, but I get the general shape of my parabola here. Okay, so here's my parabola, and now from here I want to find the focus. Well, let's find the focal length. The focal length is 1 over 4a. So I plug in what I know. I know 1 over 4 times a, which is a negative 1/2. So what I end up with here, when I calculate this, I get 1 over 4 times a negative 1/2 is a negative 2, so I get a negative 1/2. So the focal length is a negative 1/2. And again, this wants to be inside the parabola, so when I graph the focus, I just have to go 1/2 away from this thing. And the reason it's coming out as a negative 1/2, it's telling me to go down a half. And so my focal point, I'll do it in purple here so we can see it, it's going to be right here. Okay. And so now we can kind of see that ordered pair. We see that the ordered pair is negative 2. And then instead of going up 5, it looks like it's only up 4.5. And so when you look at that, you can see how it's different from the vertex. Really, I just went down 1/2 from the y value. All right. The directrix is the same thing. If I know the focal length is negative 1/2, I just have to go 1/2 in the other direction to graph this guy. So it's going to give me a horizontal line because it's got to be perpendicular to the axis of symmetry. That is a really ugly horizontal line, but I'm just going to have to live with it. And I can see the equation of that line now is y equals 5.5. Okay, so keep that in mind. Root 1 is a decimal, 1 is a fraction. That's a little weird. Keep in mind kind of the relationship that you see here between the focus and the directrix, and it should allow us to graph those and come up with the equations. All right. If I look at the next one, you'll notice here that this one is kind of in a different format. I've got x equals instead of y equals, and then I have y squared instead of x squared. So this one is going to be a horizontal parabola. So if you want to think of it this way, think about the inverse of this thing. If I think about the inverse of this guy, the inverse would be y equals 1/4 x squared minus x plus 3. Okay? So if I think about the inverse, all right, and if we look pretty closely here at this one, if we think about how we graphed this thing and approach this in the same way, all right, so think about this guy. When I look at something like this guy, if I do the vertex opposite of b over 2a, when I find the vertex the way I normally did, I get 2, 2. When I find the axis of symmetry, I get x equals a 2. And then from there, I might find something like the y-intercept, which is 3. And I won't worry about the focus and directrix until I go to graph this thing, but if I think about the y-intercept, that equals 3. Well, let's think about that in terms of the inverse then. So if I switch the x and the y back to my original problem, well, I would just switch this ordered pair to 2, 2. Poor example for this one, but really doesn't change much. The axis of symmetry then, instead of x equals 2, it's going to end up being y equals 2 because I've switched the x and the y. And so when I look at something like the y-intercept, instead I'm going to have the x-intercept at 3. Okay, because essentially, again, I'm switching each of these ordered pairs, and basically what happens now is everything that applied for x before now applies to y. So when I did the opposite of b over 2a, it gives me the y value instead of the x value. And then when I plug it back in, it gives me the x value instead of the y value. The axis of symmetry now is y equals the y value. All right, this constant term that's on the end now, instead of being the y-intercept, is now the x-intercept. So everything is just flipped. Everything that we applied to x before now applies to y. Everything that applies to y now applies to x. Okay? So now let's graph this thing. If I go 2, 2, it's right here. I've got an axis of symmetry right here. If I plot that guy, notice that's a horizontal line now because this one's going to open left and right. And if we apply the same things we know about parabolas that open up and down, if I look at the a value being positive is now going to signify that this thing opens to the left. Opens to the right instead of the left, and we can also see the x-intercept is going to help us with that if I reflect that. And I'm going to have 1/4 of the original height of this thing, so I kind of get this sideways parabola that's awfully wide. All right, so it's the same thing that we did when we graphed these vertically, except now instead of vertically we're horizontal. Everything's still the same except the things that we did for x before we now do for y. The things that we did for y we now do for x. Okay. The focus, again, if I find the focal length, that's 1 over 4a. So that's 1 over 4 times 1/4. So that's going to give me 1 over 1, which is 1. So the focal length is 1. So if I move 1, and again, the focus has to be inside the parabola. So if I go over 1, it's going to put me right here. So I can see my focus is the point 3, 2. The directrix would be in the opposite direction, so I would go 1 in the other direction and go here. And again, it's got to be perpendicular to the axis of symmetry, so that's going to be a vertical line. And now you can see the equation of that is x equals 1. All right? So again, we're still doing the same things we did before. We've got that one addition of the focus and the directrix, which really are plotted the same way by finding the focal length and then counting from the vertex in either direction. Okay?